Hello guys, welcome to my newly created channel Techie Tech. Through this channel, I will be discussing about various electronics components, microcontrollers, coding, and will be doing projects with those. In this regard, my first series of videos is going to be about Arduino UNO, which is quite a popular name in this field. So without wasting any time, let's get started. So, Arduino UNO is basically a microcontroller based development board. First of all, you can see a glimpse of this device on your screen. Now the question is, why do we even need that? Well, in a sentence, to make our life easier. We can solve real life problems with it. For example, if you find it annoying to manually check water level in tank and turning on and switch it off the pump accordingly, then with the help of this device and some other components, you can automate the entire process. You just need to instruct the Arduino UNO about its job and make necessary connections, and that's it. In this case, a sensor will tell Arduino UNO about water level of the tank. Then Arduino will decide whether to turn on the pump or switch it off based on the water level. Then it eventually turns on or switch it off the pump using the relay. Like this, you can solve thousands of problems and make your home a smart one. And at the center of the home, there will be a microcontroller like Arduino UNO. Now, as it sounds interesting, let's move ahead and get a basic understanding of it. For simpler understanding of this, let me compare this Arduino UNO with a smartphone. A smartphone has a processor as its core part that runs on certain clock frequency, like 2 GHz, 2.5 GHz, etc. Higher the clock frequency, faster the processor performs. It is the brain of smartphones. Then there is memory. Memory is the part where codes or instructions are stored, which is basically the operating system and other applications as we know. Processor reads those instructions stored in memory and executes accordingly. Also at times, processor used to store data in memory, which makes the data flow between these two a bidirectional one. Then there are some input devices or sensors like screen, camera, microphone, etc., which takes input from outside and sends to the processor for processing. And some output devices like the screen itself, speaker, etc., which takes data from the microprocessor and sends to the user. And most importantly, a built-in battery to power up all the mentioned components. So in short, a smartphone is instructed to receive data from input devices, process those, and perform certain tasks with the help of output devices. And the instruction is in the form of operating system or applications. Likewise, Arduino UNO also have a microcontroller, which is analogous to the microprocessor that smartphones have. It also has some amount of memory as well to store codes or instructions, and so that it can perform according to those codes. However, in this case, the memory unit is inbuilt in the microcontroller chip. But in case of smartphones, microprocessor does not have those inbuilt memory. It is external to the microprocessor. Again, like the smartphones, UNO's microcontroller reads those instructions from its built-in memory and performs tasks accordingly. Next, there are some pinouts, which can be used for connecting both input and output devices. In this case, as the pins can be used for both input and output devices, we need to tell the microcontroller that exactly for what purpose are we going to use all those pins. We will see this process in coding part of this video series. Lastly, the board does not come with a built-in battery, but does have some provisions for powering up its components. Here also, the microcontroller is fed with some lines of codes which it follows during runtime. The code makes it do certain tasks along with receiving data from input devices and sending data through output devices. Now, as we have known some basics about Arduino UNO, let's see how it looks in reality and identify the components as mentioned. Let's begin with the brain, that is the microcontroller, namely Atmega 328P. For now, let's skip the detailed specifications, just have a look at its memory. It has a 32 KB flash memory, which is non-volatile in nature, where the code or program is stored. It has to be a non-volatile memory because when the board is switched off, it still needs to retain the code so that it can execute it after rebooting. a 2 KB SRAM, which stands for Static Random Access Memory. It is volatile in nature, that means it loses all data when it powered off. It operates in running conditions only. Then there is 1 KB non-volatile EEPROM, which is meant to store some variable as required. Full form of it is Electronically Erasable Programmable Read-Only Memory. We will learn about those memories in details in later videos. Let's now jump onto the crystal oscillator, which is directly associated with the microcontroller. The pulse provided by this oscillator is required for functioning of the microcontroller. The more the frequency of the oscillator, the faster the microcontroller runs. However, there is a limit of clock frequency that the microcontroller supports. In this board, it is 16 MHz. Now let's look at the USB Type-B socket. This is used to communicate with computers or smartphones via a USB cable. It is that part of the board through which we will upload the code from computer to the microcontroller. Now the USB protocol used by computers cannot be understood by the microcontroller. It only recognizes TTL protocol. So to make a bridge between these two, a USB to TTL converter is required, which you can see on your screen. It acts like a translator between the computer and microcontroller. Now the entire operation needs electric power in the range of 7 to 12 volts recommended, which can be fed to this by multiple means. One of those means is of course the USB socket, as it has plus 5 volt and ground pin through which Arduino draws power from computer. Another path to power the board is through the power socket as shown. Any battery set of range within 7 to 12 volt can be connected through this socket. The last path is to directly connect positive and ground of a DC power to V-in and ground pin of the board. These two pins are internally connected to the power socket as mentioned earlier. When powering this board, make sure that only one of those three powering schemes is being used. Avoid powering it by more than one means, as it will cause undesired electrical connection between the power sources. For example, if you are powering it with USB cable from computer or smartphone, avoid connecting with a battery or other DC supply, and vice versa. Although Arduino UNO supports a 7 to 12 volt supply range, the microcontroller supports a steady voltage of 5 volt only. For this, a 5 volt regulator IC is placed on the board to stabilize the input voltage to 5 volt and then powering the microcontroller. Then there is a onboard reset button. As the name suggests, it resets the microcontroller. Means it starts executing the uploaded code from beginning after pressing the button. And lastly, a few GPIO pins for connecting with input and output devices. Here you can see in the white circle on the right side 0 to 13, total 14 numbers of digital pins, out of which pin number 3, 5, 6, 9, 10 and 11 can give PWM output. Inside the white circle on the left hand side, there are 6 pins, A0 to A5. These are analog pins, hence these pins can read analog values. We will learn about these pins in details in next video. So as we have known, there are two parts while playing with Arduino UNO. First, a hardware connection between the microcontroller and input-output devices and power sources. And secondly, building instructions, that is coding. We will code in embedded C language in applications, namely Arduino IDE and Platform IO extension of VS Code. In later videos, we will learn it in details. Now that was some basics about Arduino UNO and the components it has. In the next video, we will see the detailed pinout diagram and respective functions of those pins. So stay tuned to my channel and do like, share and subscribe if you found this effort helpful. Don't forget to press the bell icon to never miss an update from this channel. Your feedback in the comment section will be highly appreciated. Thank you.